There we go. Okay, so hopefully now we're going to get, so that was parabola. We also saw the hyperbola, y equals 1 over x. What I want to look at now are circles. We're going to look at circles. So for circles, basically to have a circle, you know, if you were asked to draw a circle in the Cartesian plane, you would need at the very minimum, you would need a point and a radius. You could actually draw it if you have 2 points, but to actually get an equation of a circle, that is to find the equation whose graph is a circle, you have to know the center and you have to have the radius. That's what we have here. Namely, if we have a circle whose center, let's see if I could draw that, whose center is that point HK. So this is our point here. And if r is the radius, which is positive, and r is positive, by definition, the circle with center at HK and radius r, it's all points in the Cartesian plane whose distance from HK is r. That's just the definition. So you're looking at all points that are the same distance from the center, which is HK. So this is the center. So let me see if I can draw it. H. Oh boy. Okay, so hopefully you can see this is the center. Any point on the circle is r units away from the center. Every point is. And in fact, such a circle is the graph of this equation. And you should be thinking of the distance formula, at least I hope you are, because that's actually where this graph, this equation comes from, the distance formula. Again, the circle is all points that are r units. Their distance from the center is r. So you can use the distance formula to get an equation of that wonderful circle. In fact, this is actually what we call, well, of course the picture's there when I drew it on the other course over here. This is actually the standard form of the equation of a circle, right? So this is our circle. Every point on the circle is r units, or its distance is r from the center. Again, that's just a definition of what a circle is. Notice here you have 2 squares. Actually, no, 3, never mind. There is actually something more general, namely, the book goes a little more into this. There is another way of writing an equation of a circle, but to understand that, we would need the concept of completing the square. That is fun, but unfortunately, for time consideration, I'm not covering that. So, all right. I mean, if you were to if you were to factor these two, you would have x squared there and y squared. So, but that's what we get for a circle. So here's an example. If we were to graph the circle, okay, that is the graph of this equation. Well, if you were to look at this and compare the standard form, right? Here's the form. X minus h squared plus y minus k squared, right? HK is the center. HK is the center. Hopefully you can see the, how do I say it, the pattern. You know, x minus the x coordinate of the center, y minus the k coordinate of the center, as you can see. The y coordinate, I'm sorry, I said k coordinate, and the radius is squared. So for this one, we have x minus 1 squared, y minus 3 squared. The center is 1, 3. 1, 3. And the wonderful radius is, this is r squared, so the radius is the square root of this, which is 2. Right? If you went back to this, the radius, it's equal to r squared, where r is the radius. So basically from here, you should be able to see the pattern, okay, how you get the center and the radius. At least I hope you can. I actually drew this using GeoGebra. I definitely did not draw this by hand. I cannot draw a perfect circle by hand. I'm sure there are people that know how to, but I'm not one of them. But the radius is 2 units long. That's what this 2 is here. And this is the center. Now here, okay, I hope this makes sense. Here we have a special kind of circle. This is actually, and of course this is not the graph of it, this is actually a circle that you use in when you're dealing with trigonometry. We're not going to do that, but I know in pre-calculus, if you go into Math 105, they will. But this circle, right, we can think of that as, this is the same thing as, remember, it's x minus, so it's x minus 0 squared. Same thing with y plus y minus 0 squared. And that's all equal to 1 squared. 1 squared we know is 1. So this can be written this way. So hopefully now you can see that the center of this circle is the origin, 0, 0. The radius is 1. Okay, so this is not that circle, unfortunately. The radius is the square root of 1. I don't want to graph it now because I don't want to deviate too much from the notes. Okay, so this I got to fix. I'm sorry about that. But it's actually, that's what the circle looks like. I mean, if you were to draw it, it would be something down here. Afraid to try. But since this circle is so important, it's called the unit circle. So again, it's not this. This is the wrong circle. This is from the previous example. But we have what's called the unit circle. So that's the circle whose center is 0, 0. The radius is the square root of 1, which is 1. Okay. Are there any questions on this? Okay. I mean, I did have some examples here. I'm not going to be able to finish it, but I'll go through this. If you want to find a circle, let's say, with a given center and a given radius, that's actually pretty easy. You just use the standard form. So for the first one, the center has to be 2, 4, right? And the radius has to be 2. Okay, so for the first one, right, remember this is the circle centered at AB, radius R. So essentially AB is being replaced by 2, 4. See? That's what I'm saying here. You know, remember, if 2 points are different, if two ordered pairs are the same, right, their x coordinates are the same, and their y coordinates have to be the same. In other words, we're going to have x minus 2 squared plus y minus 4 squared. The radius is 2. It all has to equal to r squared. So this has to equal to 4 because 4 is 2 squared. So again, I'm just basically replacing A with 2, I'm replacing, I was right, I'm replacing B with 4, R with 2. Yeah. For B, it's the same thing. The only thing I think you should get from B, though, is that since the coordinates are negative, okay, you're going to have x minus the negative, right? And that's not really the best way to write it, so it should be x plus 1. And same thing over here for y. It should be y plus 3. So that's really what it should be. Okay. Okay. So again, it's x plus 1 and y plus 3. I mean, if you happen to, without by mistake, right, minus a negative on an exam or quiz with me, I'm not going to take points off for that. But my understanding is it's better to just write that as addition. So, all right, I think we're actually out of time. So are there any last minute questions, or because otherwise we'll just stop now. It's 12:50. All right, well, have a nice weekend, everyone.